Assalamualaikum and salam sejahtera. My name is Nora Shamituskanain and my metric number is AF230024. So my part is to explain the introduction part. First, in order to manage floods, droughts, and water resources, ecosystem health, the global hydrological cycle, and also the causes of local flooding, hydrological monitoring is essential. Water shortage are also monitored. Sustainable water usage for the industry, agriculture, and consumption is guaranteed. Aquatic habitat balance is preserved, and flood risks are predicted and also managed with the aid of early warning system and flood barrier. In order to better understand local hydrological condition and create efficient flood control plans, the research intends to track rainfall and also water level trend at three rainfall stations, which are Sungai Lebih at Kuala Lumpur, Sungai Galas at Limau Kasturi, and also Sungai Galas at Ladang Mentara. Our case study is at Gua Musang, Kelantan.
So, me is Faris Aiman. I will explain about the methodology. Methodology involves systematic analysis using scientific methods to answer research questions. The study analyzed rainfall and water level data obtained from the public info Banjir website. The data focus on the 5 years with the highest monthly rainfall after gathering 1 year worth of the data to meet the study objective. Actually, we're using Google Earth Pro, which is Google Earth Pro is a free, user-friendly GIS tool that creates accurate global maps, making it an ideal starting point for students new to GIS. GIS is, for your information, is a geographical information system. Next methodology is a method of collection data. The first one is rainfall data, the next arithmetic mean method, Thyssen polygon method, isophysical method, water level data, hydrograph of rainfall data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Ahmad. My metric number is CF230206. Okay, now I'm going to show about the precipitation and water level data that we extract from official portal for Department of Irrigation and Drainage. Okay, for the data that we pick the highest event rainfall at the same time and date with the water level for the period of 1 year from 1 November 2023 until 1 November 2024. For the 3 stations that was chosen, there is Ladang Mentara F2, Limau Kasturi F1, and Kuala Lumpur F1. We found out that the highest event rainfall is on November 2000. For the catchment area, the catchment area is a basin-shaped area of land bounded by natural features such as hill or mountains, from which surface and subsurface water flow into stream or river and wetland. Okay. Water flow into and collect in the lowest area in the landscape. Okay, from this study, we have determined our catchment areas for 3 stations that we choose, bounded by the peak of the hill, the highest of the hill, and then in the catchment area we have stream or river. Okay, this is for mean area rainfall. Okay, the mean area precipitation or rainfall (MAP) is an estimation of the average depth of precipitation over a region for a specific time interval. There is accurate estimation of mean rainfall or mean area precipitation over a region or watershed is essential for hydrologic modeling effort that rely on lump simulation model. Okay, there is 3 parameters to find out the mean area rainfall. There is arithmetic average, Thyssen polygon, and the last one is isohydrate method. Okay, for the arithmetic average, this method assumes that the rainfall field is homogeneous and that's all the rain gauge are independent and give equal weight. And for the Thyssen polygon, this method divides the area into Thyssen polygon, assuming that the rainfall is homogeneous within each polygon coverage area. This method is suitable for flat or low-lying terrain, but there is not for mountainous terrain. Okay. For isohydrate method, this interpolation technique calculates isohydrate, which are lines that join equal precipitation. This method is suitable when the rain gauge network is dense. Okay, that is for arithmetic mean method. Okay, the data that we pick is for 7 days with the most precipitation or rainfall event from the chosen month, that is November 2024, and at the 3 station, there is the date from 24 November until 30 November. Okay, for the arithmetic mean method calculation, okay, the formula given is average precipitation depth equal to the sum of precipitation depth at gauge I within the topographic basin, divided by the total number of gauge station within the topographic basin. Okay. For our case, the average precipitation depth equal to 1 over 3 multiplied by 206 plus 363 and plus 328. After that, we get the answer is 299 millimeters. This for Thiessen polygon method. This another graphical technique which calculates station weight based on the relative areas of each measurement station in the Thiessen polygon network. The individual weight are multiplied by the station observation and the value are summed to obtain the areal average precipitation. As we can see from the figure below, that divided into three polygon areas or three polygon shape. Okay, this is some step for constructing Thiessen polygon. Okay. For the first step is connect neighboring station to form a triangle shape. And then to draw the perpendicular bisector of each triangle side. And then for each station, the bisector surrounding it to form a polygon. And the last one is weight of rainfall that measure at each station by its area of each polygon. Okay, the Thiessen polygon method is also known as the Voronoi. This is the data that we get from the three station, the area of the polygons and precipitation that by the each station, and then we multiply the area with the precipitation. For Thiessen polygon method, okay, average precipitation depth equal to the sum of area sub-area at each station or a polygon area, then time with the precipitation depth at each station and divide by the total area. Okay.
One of the calculation we do is Asahyatal method. So as you guys can see, this is the catchment area that we find on the Google Earth. So this is the calculation. The first one is you have a Asahyatal range. The second one, average Asahyatal range. The next one is area, and the last one is P multiply area. P is precipitation multiply area. So how to find the P precipitation average is sum of P multiply A divided by area. So the answer is 45.0309 millimeter.
So this is the cross-section profile explanation. We took Sungai Galas as our cross-section profile that offers vital details on the physical attributes of the river, impacting sediment transport, flood hazards, and also hydrological behavior in order to balance the demands of growth with environmental possibility. It supports ecological research, infrastructure planning, and also the flood management. So this is our three cross-section profile, which is upstream, middle stream, and also downstream from Sungai Galas.
Hi, my name is Nufitri Alia, AF230046. So I'm going to introduce to you guys about the hydrograph. A hydrograph is a graph that illustrates the variance in a river or stream's water flow, which is discharge, over time following a rainstorm event. It indicates the amount and the speed at which rainwater enters the river. So there are four important components of a hydrograph. The first one is the rising limb, which is the area where the flow begins to increase as rainwater enters the river. Second one is peak flow, which is the graph's highest point, indicating the greatest discharge. The third one is the section where the flows slow down as the water levels stabilize, is known as falling limb. So the last one is the base flow, which is the river's typical flow both before and after the precipitation event. Next is the straight line method for hydrograph. So the first step is to identify the start of the runoff on the rising limb of the hydrograph, which is point A. Second one is to choose a point on the falling limb, which is point B. Then draw a straight line from point A to point B. The line represents the base flow. So the last one is subtractive base flow from the total hydrograph to get the direct runoff hydrograph. Next, I'm going to explain a little about unit hydrograph. A unit hydrograph is a unique kind of hydrograph that illustrates how a river reacts to precisely 1 inch or 1 millimeter of precipitation over a given region and the period of time. So there are three important characteristics of a unit hydrograph. The first one is it makes the assumption that the area will see consistent rainfall. Second one is direct runoff is displayed, excluding base flow. The third one is to estimate river flow for varying rainfall amounts and durations. It can be scaled. So next is the three step of straight line method for unit hydrograph. So the first one is start with a total hydrograph, then use the straight line method to separate the base flow, same as the hydrograph straight line method. So the second one is to calculate the area under the BRH curve. This represents the total runoff value. So the last one is divide the total runoff volume by the rainfall depth to get the unit hydrograph. Okay, I'm going to explain the difference between the hydrograph and unit hydrographs. So first one, hydrograph show the total river flow, and the unit hydrograph show a river flow per unit rainfall. Second one, hydrograph includes base flow. The unit hydrograph excludes base flow. It only calculates the only direct runoff. So the last one, hydrograph cannot be scaled, and the unit hydrograph can be scaled for different rainfall amounts.
So this is our conclusion for this video presentation, which is in order to determine the runoff discharge for the drainage design, the study examined many approaches. It's concluded that because of its affordability, easy of use, and also accessibility, no one approach is appropriate for every catchment region. In basins with little hydrological data, the logical formula which takes into account yearly rainfall intensities is appropriate for determining runoff discharge. However, the scarcity of runoff data and the expensive expense of acquiring such data prevent the unit hydrograph approach, which yield the most accurate peak flow predictions, from being widely adopted. It is frequently utilized for forecasting even when design storm peak discharge is overestimated.